Hello everyone and welcome to our discussion on bias theorem, a fundamental concept in probability theory and random process. Bias theorem is a powerful tool for updating probabilities based on new evidence or information. It's widely used in various fields including statistics, engineering, economics, and artificial intelligence. What is Bayes' theorem? Bayes' theorem is a mathematical formula that describes how to update the probability of hypotheses based on new evidence. It's named after Thomas Bayes, an 18th century mathematician who first proposed the idea. The theorem is stated as follows. Basic concepts. Probability quantifies uncertainty. Events can be independent or dependent. Conditionally probability is crucial. Key definitions is probability theory provide the framework for modeling random phenomena in helps understand the likelihood of outcomes. Introducing Bayes' theorem formula and intuition. P of A oblique B is equal to P of B oblique A, P of A upon P of B. Bayes' theorem updates our beliefs based on new evidence. It's a powerful tool for inverse probability problems. This formula links prior knowledge with new observation. It provides a structured way to revise probabilities. Prior probability means this is our initial belief about the probability of A before observing any evidence. Likelihood, this is the probability of observing the evidence B if A is true. Marginal probability, this is the probability of observing the evidence B regardless of whether A is true or not. Posterior probability means this is the updated probability of A after observing the evidence B. Example, suppose we have a medical test for a disease that affect 1% of the population. The test is 90% occurred for people who have the disease and 95% accurate for people who don't have the disease. If a person tests positive, what's the probability that they actually have the disease? Let's define the event. A, the person has the disease. B, the person tests positive. We know P of A 0.01, B of A 0.9, accurate for people with the diseases. False positive rate for people without the diseases. Using Bayes' theorem, we can calculate the posterior probability. We need to calculate P of B, the marginal probability of testing positive. P of A union B is equal to P of B union A into P of A comma P of B. So, the probability that the person who tests positive actually has the diseases is approximately 15.38. Bayes' theorem and random processes bridging the gap. Dynamic system. Random processes evolves over time. Sequential updates. Bayes' theorem enables sequential estimation states. Filtering the prediction application in signal processing. Kalman filter optimal estimator for linear systems. Practical filter handles on nonlinear non-Gaussian systems. Signal denoising removes noise to reveal true signals. These bias filters are widely used. They process noisy sensors that to estimate underlying system states. This is crucial for GPS and robotics. Then next, computational considerations, algorithms and software. Efficient algorithms optimized for speed and accuracy, data management, handling large data sets effectively, specialized libraries, tools for Bayesian interference, implementing Bayes theorem requires robust algorithms. Software libraries provide the necessary computational power. This supports complex models and data analysis. Bayes theorem for conditional probability. There is a P of A, the probability of A occurring, P of B is equal to the probability of B occurring, P of A union B is equal to the probability of A given B, P of B oblique A is equal to the probability of B given A. Engage starts with a real world scenario illustrating the need for Bayes theorem, such as medical diagnosis or spam attention. Overview briefly explain Bayes theorem as a way to update beliefs about events based on new evidence. Key concepts is introduce the terms prior probability, posterior probability, and conditional probability. Review of basic probability is 10-15 minutes. Here is a example. Then conclusion. Conclusion: power and limitations of Bayes theorem, insights, updates, beliefs with new data, versatility, applies across diverse field, prior dependence, sensitive to initial assumptions, computational load, can be intensive for complex problems. Bayes theorem is a powerful tool for probabilistics reasoning. Understanding its strengths and weakness is key. Future advancement will surely expand its applicability. Bayes theorem is also known as Bayes rule, Bayes rule, or Bayesian reasons.